Hi, this video is produced for the ENV 347 at SUNY Plattsburgh, the Instrumentation and Water Quality Analysis course. The video today is going to show you how to set up a method. It presupposes that you've learned how to turn on the acetylene gas supply, the air supply, and how to turn on the instrument itself using the switch which is in the door on the right side and in that section down in the lower left-hand corner. So right now we're bringing up the WinLab 32 software, which is on the computer that controls the atomic absorption unit, which is a Perkin-Elmer AA Analyst 400, again in the Lake Champlain Research Institute Water Quality Lab. Just a note to be patient. This software and the recording software is running on a very old computer, and the recording software makes the AA software run fairly slowly. When we bring up the software, the first thing we'll do is establish communication with the instrument and go through a set of initialization routines shown up here in the upper left. You'll see a green check mark come up here for checking with the spectrophotometer, and another one for the flame. If the flame communication isn't established, you'll see typically see an interlock error up here. If that occurs, it means that the waste container that collects large drops that didn't make it through the nebulizer has a U-tube in it, and that U-tube is full of water, and that prevents it from being open to the air. If there's an electrical switch in that tube, and if that U-tube is not full of water, that electrical switch won't be connected, and you'll get this error message. If that happens, take a squirt bottle. There's a small hole in the top of the waste container, and you need to fill that up with water until that interlock goes away. We can close these tips of the day, and you'll see up here that everything says idle and we have no error messages. If you had error messages, you can have a log of those under the spectrophotometer and flame conditions. Okay, as soon as everything checks here, we can X out of here. You notice there the red X under the auto sampler there. That's not a problem. We don't have the auto sampler running, and that will always be present. The first thing when setting up any method is to go into the Tools and go under Recommended Conditions. And this will give you all the elements that atomic absorption can measure, which is something like 64. We'll go down and find the element that we're interested in. In this case, it's calcium. A few noteworthy things. There are two main ways to measure calcium at 422.67 nanometers. That has a linear operating range, is linear all the way up to 5 parts per million. This is good to know because typically you would want to make your standards to max out at that value, which we've had. We made a set of standards today of a blank, 0.5, 2, and 5 parts per million. It also gives some other parameters. One of the things that's important is it tells you which slit width to use. In this case, it's 2.7 nanometers. Another thing you want to check, the second wavelength here, 239, that might be useful. It maxes out at 800 milligrams per liter. If you were doing highly polluted samples or extracts of soils or something like that, that could help you prevent you from having to dilute all of your samples. Check the remarks section. It'll give you some things to look out for when you're analyzing. In particular here, it says that the signal can be depressed by interference by aluminum, phosphorus, and some other elements that are quite rare. In particular, phosphate will bind with calcium, and in the flame it won't dissociate so that calcium can't go to the ground state. Typically, in all of our samples and all of our standards, we make them up in 0.1% lanthanum in the form of lanthanum chloride or lanthanum nitrate. I've not done this today since this is just a practice routine, but we will do this in our laboratory. And with that, we can get out of here and go to our method editor. Before we do that, actually, I want to go back and here we can see an old analysis routine that we set up. I want to show you how to delete that if that's necessary. So we'll X out of here. This is a little laborious. So we'll go into File, Utilities, Data Manager. And again, be patient. It's going to have to bring up a separate set of software. Okay, you can look at results, but you can also look at methods. So we just click on this library category. Again, close that. And we'll look at methods instead of results. Click on OK. And here was a previous routine we had set up, and we can just click on that and go up here to delete it. And it'll ask us if we want to do that, and we click on OK. And that routine is then gone. So we'll X out of this. And then we'll go into our method editor. And this gives a list of methods. I'm not sure this is necessary, but we'll go down and get off that other method. And at this point, we can set up a new method. It's going to be a method for calcium. Oops. So we'll give it a name. We'll call it ENV 347 calcium. And a few parameters here. It's calcium 422.67. We could set the slit width here if we wanted to. It's going to give you two choices. We're going to stick with the 2.7. We could change it there if we wanted to. And the measurement will be a time average. That's the only choice. It's important to go to this Settings tab here. This basically tells the instrument how it's going to take readings. It's going to take each reading is going to be for 3 seconds. It actually samples about every 0.2 of a second during that 3 seconds, and it will take the average of those for that first reading. We're going to want to put it in a delay time here of probably about 3 seconds. And this is in case we've just put the tube into a particular sample. It gives it time to pull that sample up and get it equilibrated in the flame. It's actually going to take 3 replicate readings each of 3 seconds, plus the delay time adds up to about 12 seconds per sample. The lamp current is going to be in our initial conditions for the lamp setup, so we don't have to worry about that. Down here on the bottom, the auto sampler we're not worrying about because we're not using it. The next thing is the calibration window. First thing we'll tell it is how we're going to establish our standard curve. Instead of using a non-linear that goes through 0, we're going to use a linear with a calculated intercept because we know that we're inside the linear working range. 3 decimal places. We can also tell it what units we're going to use. In this case, we're going to use milligrams per liter or parts per million. On the right-hand side, next, we will tell it what our standards are going to be. In every case, it presupposes that you have a 0 standard, which is your blank. We can give that blank a name. It automatically assumes that's a concentration of 0. Then you tell it the names of your standards. We'll start off, our first standard is 0.5 milligrams per liter. It's important to realize that this is a name, just text, and is not a number. We put in the actual concentration right here to correspond to that. Go to our next standard, which is 2.0 milligrams per liter. And then finally 5.0 milligrams per liter, which is our highest standard at the top of our linear operating range. It will auto-fill an auto-sampler location, but since we're not using an auto-sampler, that's not a problem. Just about everything else in here has to do with QC checks and things like that that are not necessary to do in any kind of an initial run. So with that, we'll X out of here. This is now stored in the instrument as its current method. Now, to save that method for future use, we would actually go into Method. And at that point, it prompts us, do you want to save the changes to the method? We'll click on Yes. And we'll now give it a name to save that under, which is ENV 347 calcium. And this will save it for future use, and it won't save it on top of the other methods down there. And at that point, we've created the method. It's using this method for its current operating conditions, and we can use this exact same method for future uses. And you can also see that it indicates which method it's using up here. Otherwise, you'd have to go into the method editor to see what the current method is. So with that, I'm going to click out of here. And so we've gone through the steps in creating a method, and in the next part of this video, the next video, we'll be learning how to actually do an analysis using that method.